Hello class, today we are going to be learning about how we measure sound and why we measure sound. So with the notes that you took home today, I need you to write on the front of it, measuring sound, and write your name and your class number up top. To start off, we're going to flip to the first page, and on the back of this, you're going to need to write refresher. What is sound? And go ahead and write a definition in your own words about what sound is. And we've been talking about this in class, so I hope that you can write that in your own words. Once you're done with that, we're going to go ahead and talk about how we measure sound and what we can look at to study sound, because most of the time we can't see sound unless we see the vibrating object that sound is transmitted through. And so longitudinal or compression waves are the sound waves that we can study, and these show the direction of the wave that is traveled parallel to the direction in which the object is vibrating. And so if an object is vibrating to the right, the wave will be shown drawn to the right. If it's vibrating to the left, it will be shown to the left. Go ahead and write into your notes the definition of longitudinal or compression waves. And the reason that these are called compression waves as well is because of the compressions that are measured in sound waves. And this will make a lot more sense to you as we move on to the next page. So you can pause the video and fill in this definition, and then we can move on to the next page. So compressions are the vibrating particles of a sound source that are close together, they're compressed together. And so I have an arrow drawn in your notebook, but right here is an example of one, because you can see how the waves are a lot closer together and they're pressed together. And so these we're going to label with a C. So you can pause the video and go ahead and label the rest of your wave with the letter C in spots that you see that the waves are compressed. Now we're going to talk about refraction. Refraction is the vibrating particles in a sound source that are spread apart. And so the waves that are in between these compressions can be considered refractions because the waves are spread apart. And so we can go ahead and draw in the segments of the wave that are considered refraction. And in both of these definitions, we're talking about the sound particles, not just how these waves look. And so on your own, I want you to pause the video and draw in the different ways that you will see the sound particles of each wave. So you can see here that the sound particles in this compression wave are close together, whereas in the refraction, they're spread apart, just like how these waves appear when we study them. Next, we're going to move on to wavelength, so you can go ahead and flip your page. Wavelength is the distance between two compressions, and we talked about wavelength when we talked about light, but just the difference between measuring wavelength in sound is that it's between two compressions, not just two waves. And so here we have a close-up of the distance between the compressions and the refractions. And over here I have a more zoomed in picture of it. But right here is where you would draw these lines like this and go ahead and write in the wavelength, which over here I have the symbol for wavelength that we could be referring to at some point. And so that's called lambda, and that's another way to represent wavelength. So right here you could write wavelength, or you could write the symbol lambda. And so wavelength, when you're studying it and when you're studying the distance between the waves, it's just going to be the distance between the compressions. And so that distance is really going to be the length of the refraction. Next we can talk about frequency. And frequency is something that we talk about a lot, or you hear about a lot. Like the frequency of different sounds when you take a hearing test. The higher the frequency, the harder it is to hear. But over here I have this drawn out for you, which is exactly what's in your book. And you can just go ahead and pause the video and write in the definition, because we're going to talk about what this means in a second, but the number of vibrations in a given amount of time is considered the frequency, and it's measured in hertz. And right here is a formula that's already written for you, but you're going to need to study this so you know it when we measure sounds in class. So frequency is equal to the number of vibrations divided by the number of seconds, and it's measured in hertz, so you need to make sure that you have that unit at the end. When measuring sound and measuring the frequency, how many times the wave passes through this spot in a certain amount of time is going to be the frequency, because it's measured in how many vibrations came through this one spot that they were watching in that certain amount of time, and that will tell you the frequency of sound. On the back of your page, on the back of your book, you're going to flip the page after frequency, and you're going to go ahead and write one question, or if you have more, one question that you still have, or something that you need clarified, and we'll be able to go over that in class. Also, on the back of your booklet, I need you to go ahead and write down one real-life application that you could think of where measuring sound is extremely important and would explain why we learned to measure sound in the first place.